Hey everybody, welcome to the P11 worksheet. We're working on negative exponents and zero exponents. If you'll notice, every problem has a number to a negative exponent or to an exponent of zero. So we need to know how to deal with those. I'm actually asking for a couple things on the negative exponent problems. I'm asking you to write the answer, the first answer, as a positive exponent, and then actually evaluate that. And so what we're going to do is we need to recall that every one of these problems is actually a fraction, right? So there's a fraction line at the bottom of the term. There's nothing in the denominator, or if you want to put a value 1 there, I guess you can, no big deal. What we're doing is we need to understand what that negative exponent does. And the negative exponent allows us to move from the numerator to the denominator, and in some of the other problems we learned that it went the other way. If you had it in the denominator, the negative exponent in the denominator, you can move it to the numerator. But this is what we're looking at doing here. We want to show that we know that 3 to the third power, 3 to the positive third power, is now on the bottom if 3 to the negative third power is on top. And then we have to go one more answer here and actually calculate what is 3 to the third power. And so you want to make sure that you know what 3 times 3 times 3 is, right? 3 times itself 3 times. And that happens to be 27. If you're not sure how to do that, go ahead and work it on the on your calculator. Or if you want to, you can certainly email me if you need some help with the calculator usage. So at this point, what we're looking at is on number 3. Remember, we have our fraction line. This guy gets to move to the denominator, so our first answer is going to be 1 over 4 to the third. And then 4 to the third means 4 times itself, 3 times 4 times 4 times 4. That happens to be 64. So we have an answer of 1 over 64. I need to see both answers, not just the other one. Because if you just type this into your calculator is going to give you the final answer. I want you to show me that you know what the negative exponent does. All right. One of the things that we've learned a while ago is that the power of 0, what does a power of 0 is, and I'll remind you of the lesson that we did with that. We did something like this. We did 4 to the third, 4 to the second, 4 to the first, kind of had a pattern going, and we said, hey, what do these numbers equal? And well, we just realized that 4 to the third was 64. 4 squared means 4 times 4. That, of course, is 16, and 4 to the first power means you only got 1 4, so we get a 4. And the thing you remember that we talked about is, how do I make the pattern on this side? And every time I have to divide by 4. How do I make the pattern on this side? Well, I just keep decreasing the power, the exponent, by 1. And so that's going to make a 4 to the 0 going on here, which means I need to go one more level. And of course, I'm going to follow the same pattern. And what is 4 divided by 4? Well, that's 1. If I had a 5 in here, I would have numbers here that I would keep dividing by 5, and I would end up with a 1 there. If I had 1,000 as the base, I would have numbers, if I kept dividing by 1,000, I would end up with a 1 there. So in other words, anything to the 0 power is 1. All right, finishing up here, we have 6 to the 1/2, or to the negative 2 power. Remember, this is a fraction line. It's going to move to the bottom, so we're going to go 6 squared to the bottom, and 6 squared happens to be 36. 6 times 6. Fraction line, 2 to the negative 4 means we're going to have 2 to the positive 4 on the bottom, and 2 to the 4th power means 2 times itself 4 times. That happens to be 16, so our answer is 1 over 16. Keep your answer in the denominator if that's where it is. Don't make this answer 16 just because you calculated 2 to the 4th power on your calculator or something. Know where it's located. All right, you do the even problems, send it back to me. We'll get you reassessed on this one once we do a pretty good job on that. See ya.